Howdy, AP PreCal, it's Miss Kosh. I think this is the 10th video, is that right? Now I'm gonna go look. I think this is the 10th video that I'm making on Unit 1 from Mr. Passwater. He has all these glorious multiple choice questions and I'm working some of them. And no, I can't make the PDF available to you. So hopefully this is helpful and we're gonna go from there. So we've been doing some transformations, there's a little bit more. Okay, so what's happening here? This is, I would say in the previous years, I would have said it's a horizontal compression by a factor of 2 or a horizontal stretch by a factor of 1/2. That can get a little confusing. So what we're going to use is a dilation, and it's a dilation of 1/2. So it's not the 2, it's the 1/2. And then it says, then it's going to go up 1, followed by a vertical translation of the graph by 1, not -1. Okay, so it's this value, it's this, not value, it's that answer right there. The next one, so this was a reflection over the x-axis, so not the y-axis, and then it was shifted to the left 4, so followed by a horizontal translation left 4 by -4 units. Okay, so there's that. I don't feel like doing that one. I think some of these are kind of similar. Let's see. Oh no, number 177 looks a little different. The function is given by this. The graph of the following functions is the image of the graph k after horizontal translation of the graph. Okay, horizontal translation of the graph k units. That means I'm going to take this whole graph and shift it to the right k, which means I have to plug in this. This is an additive transformation of k that results from subtracting 4 from each input value of x. Yes. To be honest with you, I absolutely hate linear transformations. True story. But I think they're boring but confusing, if that makes sense. Like, I'm like, why do we care? They're just lines. Just graph your stinking line and whatever. When the equation gets more interesting, then the transformations on them are more interesting. But okay, just because I promised to work some of these problems and I shouldn't let my feelings get in the way. I'm laughing at myself on a Friday afternoon here. I think it's this answer, and so where all it did is we're moving, oh, hang on. Let's do window, let's do the standard window. What did it do to that graph? Yeah, it picked it up. It seems like it moved it over 4 units. We can verify by gsolve root. That seems kind of silly. Okay, so 1 2/3, and then let's do gsolve root on the other one. Come down to get the other graph. Yes, that's the one I want. And 5 2/3 was 4 more than that. Okay, so I think that's the correct answer. I find that annoying. I'm fine. It's fine. I'm fine. Okay. Did anyone catch my reference to that? That was pop culture reference. If you caught it, comment down below. Okay, so the next one, the graph is a horizontal dilation. Horizontal is the annoying one. Vertical is easy. By a factor of 3. So that means that we're going to have to do over 3. Okay, the function of f, which of the following is the image of that after horizontal dilation of the graph by a factor of 3? I'm kind of surprised that we don't see this whole thing over 3. Had we not had these choices, I would have said, okay, well, let's take the x component. Does it matter if okay, back to our calculator. I don't know if this is probably not on the calculator part, but I'm trying to help you learn as I stumble through. I don't always stumble. X minus 4, but it is 4:04 on a Friday afternoon. My tardy, or the end of the day is at 4:15. We are almost there. It's Pilates and then the weekend for me. Okay, so I was thinking it should have been, in parentheses, I was thinking it should have been an x minus 4, and then the whole thing was divided by 3, and then this thing gets squared plus 7. But they gave us the answer choice of, that's funny. I wonder if it's going to square the 3. That notation, I don't like that, because I typed it in correctly. But they gave us, I'm pretty sure I typed it in correctly. Comment below if I did not. X minus 3, and then minus 4 was an answer choice. I think this has to be right, and this is squared plus 7. Okay, so let's see. Here's our graph. The next one, I need a better window. Let's get some more y values. Say up to 20. Okay, here's our graph. What did they say? Which of the following functions is the image after a horizontal dilation by a factor of 3? So both of these actually, okay, hang on, let's get a few more x values. We'll go to 40. There's our original graph. They both have that horizontal dilation by a factor of 3. This one seems to be shifting also, which kind of bothered me, but they didn't tell us we couldn't shift. so there's that. Okay, so I think the best answer has to be C, because it's a multiplicative transformation that results from dividing each input value x by 3. Yeah, in essence, when I did that, I also shifted it, but they didn't tell me I couldn't. Well, okay, actually, let's see. Did I shift it? So what I did is I stretched it. So I stretched this value. Oh, okay, maybe we're fine. We took this value and we stretched that had an x value of wherever this minimum was. 2, maybe, probably not, but no, 4, I knew that. And then I multiplied that by 3 to get a minimum of 12. So let's look at this one. This should have a minimum of 4. Yes, that's good. G-solve, wrong button, minimum. Not that one, not that one. I want to look at this one. It should be 12. Ah, good. Okay, so that was a horizontal stretch by that. Okay, they were right. I'm tired. There we go. Let's see. What type of function models this data? Oh, okay, we'll do a couple of these, and then the bell will ring, and I will be done. Notice the x's are all increasing by 1. What's happening which is good. You always want to verify that. I don't necessarily write it down, but what was I doing here? We add 2. Here we add 5. Here we add 8. Here we add 11. Here we add 14. Now you can't read my handwriting, but basically we were adding 3 to all of those. Okay, so it's quadratic because the data demonstrates constant non-zero second differences. Yep. Polynomial degree greater than, nope. Okay, it's quadratic. We already did that side. Woohoo! Okay. Let's see what's happening here. It's there. This is linear, and this is, we added 2, we added 3, we added 3. Oh, hang on. I'm going to do it this way. 0, 1, 2, 3, 4, 5, and this was -4, -2. Can you see what I'm doing? 1, 4, 6, 6. So what did I do? I added 2, I added 3, I added 3, I added 2, I added 0. Not linear. I added 1, I added 0, I subtracted 1, I subtracted 2. Not quadratic. I subtracted 1, I subtracted 1, I subtracted 1. It's cubic. Okay, cubic, there we go. I didn't even read all the things. I'm sure it's great. Okay, so we have a Pez. I know what these were, but I didn't really eat them as a kid. Okay, so it's a Pez candy dispenser trying to minimize the cost. Manager the manager that the number of hours per day that the factory operates affects the amount of the cost. Oh my goodness. Okay, y'all, I need to go home. Of which, what is the minimum value of c of x to the nearest cent based on the model? Oh. Okay, what I would probably do is, if I had a calculator, I would type this in, 7, 8, 9, 10, and I would come over here and do 1.62 and 0.9 and 0.56 and 0.6. This may be a great problem, and I'm just tired, so my apologies to whoever I may have offended in that. Okay, we're going to calculate the quadratic regression, and I'm going to copy it into here and draw it, so it does seem to fit that data pretty well. Oh, could you see everything I was doing? Then I'm going to come back to this graph page. I'm going to turn on this one and then delete these. I don't need them anymore. Okay, and then draw. And it's in that world. Which of the following is the minimum based on the model? So I can do G solve minimum. And at this time, it's about 5.3. So, 5.30, which appears to be 53 cents. Hopefully you could see that. I wasn't really watching to see what you could see. My apologies. Okay. Oh, goodness. Y'all, I think he's got 3 more questions in total on this Unit 1. We are going to go for it. Okay, so the figure shows, it's this, the square sheet has side lengths of 24 and will be used, okay, so we're cutting out corners. Which of the following gives us a domain of X? Well, 0 is obvious. But if this is 24, excuse me, the most that I can do is get halfway there. So I think 12 is the best answer. You don't have a box anymore, but I don't know why you couldn't make it, because if you made these go all the way down to say 9, and then this one came to 9, well, that's 18, that leaves you 6, and there's no reason you can't have this little piece be 6 here. Well, okay, it would have come into the whole thing, but we could have a base that was 6 by 6, and then had a height of 9. I don't see why we couldn't do that. So it's going to have to, I would say maybe the best answer would be 0 is less than or equal to X is less than 12. Because once you get to 12, it's not a box anymore, but it's still a box between 8 and getting closer. So I think that's the answer, but if you check the answer key and I'm wrong, comment nicely down below. Okay, an electronic bowling video game challenges players with an option to bowl with an increasing number of pins. Yikes. I'm not good at bowling the regular way. Okay. Okay, this is an arithmetic function. The number of pins in a given round is best modeled by a linear function because the difference between consecutive rows is linear. No, it'd be quadratic because the difference in the consecutive rows is linear. Quadratic because the difference, no, okay, it's this one. What's happening here is that we go from, we have a total of 10, a total of 15, and a total of 21. These are triangular numbers. They're kind of fun, but this is a video for another time in another place. If you're curious, let me know. Okay, last one of his Unit 1 stuff. He notices when he sits down to write a math problem, his output is affected by how long he has been working. No kidding! Can you tell this has been one of my, me too, one of my worst videos today. I am exhausted, you guys, and I'm just pushing through. And my eyes are crossing and I can't read, so it's great. It's really fun. Okay, for the first 2 hours, he writes problems at a constant rate of 12 problems per hour. So I should see a 12T for the first one. Okay, that's great for the first 2 hours. Okay, so that fit all 4 examples. However, after 2 hours of working, he writes a problem at a constant rate of 8 hours, see, I'm telling you, 8 problems per hour until he falls asleep after writing for 6 straight hours. So we're going to stop at 6, which he did in all of them, and it's 8, he writes for 8 problems per hour until he falls asleep, which the following best models the total number of problems. I think we just need 8. Is there any reason we wouldn't want to do that? Well, okay, so let's think about this for just a second. In hour 1, okay, here's T and here's F of T. In hour 1, what has he done? He has written 12 problems. In hour 2, he's written 24 problems. In hour 3, oh no, see, I was wrong. Is this, which of the following, total number of problems, total number of problems. Okay, so he has those 24, plus now he's written 8 more, so he's at 32. And then at hour 4, where should we be? He's done these plus 8 more, he's up to 40. Okay, so if I plug in 3 into this one, I'm not getting 32, so that's why that's wrong. Good thing I paid attention a little bit more to what I was doing. I think it's going to be 24 plus this. Let's see. If I, because we had an initial amount and then at t equals 2, we're at 0, so we're still here. At 3, we've added 8 to that. At 4, we've added 16 to that. So I think this is the correct answer. Let's see why these are wrong. This would be saying if at hour 2 he's adding 16 to 24, so this one would have hour 2 be equal to, well no, it's not defined at 2. At hour 3, we're adding 24 to 24, we'd be at 48. At hour 3, we are not at 48, so that's why that's no good. And yeah, we need to have that initial amount. You guys, I just finished his going through the videos that I'm going to make for his Unit 1 multiple choice questions. Happy day! Subscribe and the bell rings. So that was, did you hear that? It was perfect timing. Okay, like, subscribe, comment, all the things, and come back for more. I'll see you next week.